Okay, so we're going to go over a little bit about how you can figure out the Bourne-Haber cycle. Right? Now, the Bourne-Haber cycle is based on a simple principle, and it's the idea that by looking at our enthalpy changes, that because they are state functions, that as long as we're going from the same reactants to the same products, that it doesn't matter what pathway we take, we can find those enthalpy changes, right? And so that kind of comes down to this concept that if we have these lithium ions and we want to find out the amount of enthalpy change that occurs when they go from their ions in the gaseous state to being a solid, we can find that by kind of looking at some different pieces that we might have already known or that we might have already measured and looking at those enthalpy changes. So for an example, we are going to take this heat of formation reaction, so number 6, that's where we go from lithium as a solid and half of a chlorine gas molecule, and we turn that into lithium chloride as a solid. We know that energy change, that's already been measured, that's something that's standardized, and we're going to compare that to this other series of reactions where we don't know step number 5. Step number 5 is the amount of energy that gets released when we go from being the ions in the gaseous phase down to their solid. And so we can kind of compare steps 1, 2, 3, 4, and 5 versus step 6. And that's going to help us isolate step 5, which is actually our lattice energy. So the first part about it is we have to identify each of those points. So how you kind of read this is that each of these squares is kind of like our reactants. And each of the square that we're moving into would then be our products, and we're kind of looking for the change. So for step 1, I'm looking at changing my chlorine gas molecule into just a chlorine gas atom. And so I'm trying to think about what that process looks like. And you can kind of describe it as this change here. Taking half of that chlorine gas molecule and breaking it into a chlorine gas ion just by its, or not an ion, but an atom by itself. And that's going to be related to the bond enthalpy. The bond enthalpy is the amount of energy that's stored inside of that bond. And so the bond enthalpy kind of tells us how much energy we would need to put in order to break apart that chlorine molecule. Now, bond enthalpy is typically given in 1 mole of the molecules. So that's why we have 242 kilojoules per mole of CO2 gas, right? Which is a little bit different than our reaction. So we're going to have to modify that. For number 2, the change is that our chlorine has stayed the same, but our lithium has changed. Our lithium has gone from being a solid to a gas. Now that doesn't look like a chemical change since they're the same material. And instead that's a physical change. And that's the amount of energy that would be required to cause sublimation to go from a solid to a gas. And so we have the enthalpy of sublimation there. The difference for step 3, we're kind of looking at this and chlorine looks the same, but our lithium has changed. Instead of being an atom, it's now an ion. You can see that we've kind of changed our lithium to a cation. And the other part is that we now have an electron that was produced by that. And so that's the ionization energy of our lithium, right? We're taking that atom and we're ionizing it. We're separating an electron away to produce its cation. And so that's going to be my first ionization energy. Step 4, we're kind of looking from this one over here. You can see that what has happened is my chlorine now has changed. My lithium's still an ion, but my chlorine has now become an anion. So it's kind of like that chlorine atom has picked up an electron. Now that, when you gain an electron to become an ion, that's called electron affinity. So we have our first electron affinity. And then for step 5 is our lattice energy, the amount of energy that we kind of gain back when we transition from our ions into our solid. And that's the part that we're looking for. Now we're just comparing that against step 6. And step 6 is our enthalpy of formation. It is us making 1 mole of that product, lithium chloride, as a solid, starting from its elemental states here. And so now what I'm going to do is I'm going to try to convert these over. And so my relationship is going to be that the enthalpy change of step 6 is going to be equal to the enthalpy change of step 1 plus the enthalpy change of step 2 plus the enthalpy change of step 3 plus the enthalpy change of step 4 plus the enthalpy change of step 5. So I'm kind of comparing this pathway versus this pathway, because they both should add up and be equal to each other, because we're going from the same initial to the same final. So we know that enthalpy change for number 6, that's negative 408.3 kilojoules per mole. What we need to find now is that change for these other ones. So now I'm going to slide this on over a little bit, if we can, just to kind of give us a little bit more space for this. No, apparently I can't slide it over. Let's try to see if we can zoom out a little bit. I guess that's a little bit better, but we'll see. No. Okay, hold on 1 second. Okay, so I was able to shrink it down just a tiny bit. So now we want to think about the enthalpy change of step 1. Now remember, step 1 is our bond enthalpy, and so we're breaking that molecule apart. Now we have the energy for 1 entire mole of it, but we don't actually need 1 entire mole. Because we're only dealing with half of a mole of our chlorine here, then we want to make sure that we only use half of that enthalpy change. Right? So half a mole of chlorine only gives us half a mole of our enthalpy. So we want to take 1/2, 242 kilojoules per mole. Now, we don't have to do anything for the part 2. That's ready for 1 mole. So that's 147.1 kilojoules. For step 3, also don't have to do anything. Also, for our 1. Step 4, we're also looking at negative 349. And we're going to add to all of that the enthalpy change of step 5, which we don't know. So I'm going to kind of condense this down a little bit. This becomes negative 408.3 kilojoules per mole. This becomes 121 plus 147.1 plus 520.2 minus 349.0. So that becomes 400, oh, wrong colors. 439.3 kilojoules per mole plus the enthalpy change of number 5. And since we're looking for that enthalpy change of number 5, we can take that 439.3, we can subtract both sides by it. This becomes negative 847 kilojoules per mole. And that becomes delta H, step 5. So now this change becomes negative 847.6 kilojoules per mole. And typically when we talk about lattice energies, we give them as a positive value. And so this would become 847.6. Now, your Bourne-Haber cycle could have more steps to this. You might have to go through 2 ionization energies, right? 1 plus 2. And that might be because you might be going from calcium as a solid to calcium plus 1, and then to calcium 2 plus. Right? So you want to make sure that you do each of those steps. We also have to make sure that we are still turning them into all of the correct states, right? So if it's a solid, we really should turn it into a gas first, and then we should ionize them. Right? So you want to make sure that you're doing all of those steps. But it all comes down to this state law, right? Hess's law, that as we compare our different pathways, if we can know one side of it, then we can use that to kind of figure out the other side as we're kind of working our way through the whole thing. So the big part is trying to look at each of those steps and identify what is the change between them. And then trying to connect that with your knowledge and your understanding of some of these terms. And so a big thing to start with is knowing your definitions of what an ionization energy is, knowing the definition of electron affinity, knowing your definition of a lattice energy, knowing your definitions of the enthalpy of formation. All those things, all those names of all of those names of those processes is starting to come together now. And so you really want to make sure that you're internalizing them and that you know them for this next part. Okay, I hope that helps.